Unit 2, specimen paper. Okay. Question number 1. Which alkane has the highest boiling temperature? So, boiling means it's going to depend on the of intermolecular. Okay. So, if you can, it's 2 it has propane. So, how many die in carbon?
Sir,
I
you're
can see
lagging
a
a
screen.
lot.
Sorry?
You're lagging a lot. I'm not sure if it's only me, but you're lagging.
भाई कि बाकियों को भी लैग कर रहा हूँ मैं
जी सर, लैग कर रहे हैं आप।
जस्ट 1 मिनट दे मुझे फिर
Sir, is it you?
yes now better
Yes.
Yes, sir.
okay good
सर ये कौन से ईयर का पास पेपर है?
ये स्पेसिमेन पेपर होते हैं क्या नाम है अब्दुल्ला हर 3 साल बाद अपलोड होते हैं ये बेसिकली इसे काफी आप देखोगे कि क्वेश्चंस आ रहे होते हैं मतलब काफी का
ओके।
मतलब ये है कि 1-2 क्वेश्चंस इससे आ जाते हैं आराम से इजीली तो आप देखोगे कि 2-3 स्पेसिमेन पेपर आपको मिल जाएंगे आराम से इतना कोई बड़ी बात नहीं है ओके मुझे आई हैव टू रिकॉर्ड अगेन इट्स डैमेज्ड okay so I was saying ke which alkane has the highest boiling temperature so of course it would be like if you can see option C it's totally wrong. It's totally wrong. Why? Because it has 4 carbon atoms. The number of carbons are directly proportional to the melting and boiling point and is directly proportional to the intermolecular force of attraction. Okay. So if I can draw the structure for A, it would be 2,2-dimethyl propane. 2,2 2,2-dimethyl propane. So it has the branch structure. Okay, so means that the surface area is lower, intermolecular force would be lower, the boiling point would be lower. If you can compare with this D option, its straight chain structure means that the surface area is higher. When the surface area is larger, so the intermolecular force would be higher, so the boiling point would be higher. So option D would be the correct answer, because which alkane has the highest? So option D would be the correct option, okay? Because in this option, the intermolecular force is higher as the surface area is higher, okay? Then question number 2 says, which is the order of increasing boiling temperature? So then we have to see, of course, in W, you can see 3OH. 3OH. So means that it's supposed to have the highest boiling temperature. It's supposed to have the highest boiling temperature. So means that increasing order. Increasing means that it starts from lowest to the highest. So the highest would be W, means that it may be A, it may be B. Okay, C and D are completely wrong option. Then we have to see which is going to have the lowest boiling temperature. Of course, it doesn't have any functional group, like it doesn't have any OH. You know, OH is going to make hydrogen bonding. Due to that, we can say the intermolecular force of attraction would be higher. Okay, so it doesn't have any OH group, so the intermolecular force would be lower. So of course it would be having the lowest boiling temperature. So that's why the answer would be, again, it may be A, it may be B. Why the same option? Then we have to see X and Z. Okay, in this we have only one OH, in this we have two OH. So the number of OH increases, so the intermolecular force increases, so the boiling temperature would be increases, so would be increasing. So that's why Z is supposed to have the highest one. So option B is correct. Okay, this is the correct order from the lowest to the highest. That's it. Question number 3. Which statement is not explained by hydrogen bonding? Hydrogen bonding is a type of intermolecular force, IMF. All group 1 hydroxides are soluble in water. Okay. Many simple alcohols are soluble in water. The density of ice is less than the density of liquid water. The melting temperature of water is abnormally high. They are saying which statement is not explained by, is explained by the hydrogen bonding. So remember, they are saying all group 1 hydroxides are soluble in water. You know, you know, hydrogen bonding means that uh, it's going to have the higher boiling temperature. Okay, and it's a type of intermolecular force, it's not intramolecular. You know, group 1 hydroxides means that sodium hydroxide, lithium hydroxide, potassium hydroxide. When something gets soluble in water, it dissociates into this. You know, it dissociates into Na positive, OH negative, Li positive, OH negative, K positive, OH negative. So it's not a hydrogen bonding. It's a simple ionic compound is going to dissociate. It's going to ionize. So option A is the correct option. So this is the statement which is not explained by the hydrogen bonding. It's going to have ionic bonding. Ionic compound is going to break down into the respective ions. And when it's going to break down, when it would be forming an ion, so then I can say that it would be soluble in water. Simple. Question number 4. Which compound is hydrolyzed most rapidly? 1-chloropropane means that 1-chloropropane would be like that. 1-chlorobutane would be like that. 2-chloromethyl propane would be like that. Then 2-chlorobutane would be like that. Okay. So which compound is hydrolyzed? You know what does it mean? When you are going to react it with water, okay, just like that. So it would be forming this one. Chlorine is substituted by OH. Chlorine is substituted by OH. Remember, okay? So when we were discussing alkene, so I told you regarding the carbocation. I told you regarding the carbocation, primary carbocation, secondary carbocation, tertiary carbocation, and I told you that the tertiary carbocation is more stable one because if you can see this one, if you can see this one, it's positive charge, okay, and
So,
the
sir, that means that it's gonna be hydrolyzed the least rapidly, right? If it's more stable.
uh, you know when the positive charge is balanced, the positive charge is balanced, so means that these these alkyl groups are going to donate electron to this charge, okay. It's going to weaken the carbon and chlorine bond. It's going to weaken the carbon and chlorine bond. So it can be easily broken down and it can be easily replaced by the coming OH group. So it would be forming easily this one compound that would be just like that. So this is the one which is going to hydrolyze most rapidly because this bond can be broken down easily as compared to this one, and this one. This A and B are primary halogenoalkane, and D is secondary halogenoalkane, and C is the tertiary halogenoalkane. So the tertiary would be more stable. So that's going to weaken the bond of carbon and chlorine. As a result, less energy would be required. So the OH can be displayed or can substitute this chlorine very easily. So I can say that this compound is going to hydrolyze most rapidly. Okay, so C is your
Well,
correct option.
the carbocation.
Sorry.
One's the tertiary hydrocarbon, right?
हाँ जी. Yes.
Okay.
Sir, but
And
why do they
there's
say that
okay.
tertiary is more stable?
Tertiary is more stable because it has three R groups. R groups means they are electron donating groups. So they are going to donate electron to this positive charge. This effect is known as positive inductive effect. Due to this, this positive charge is balanced. If you have two R groups, it's less stable than the tertiary one. If you have only one R group, it's the least stable than secondary and tertiary. Okay. See this. Give the systematic name for the following molecule. So first of all, you have to decide it's cis and trans. I told you, cis means cis, like the Z isomer. I told you that means cis, like cis is Z and trans is E. Z means and its opposite side, right? So first of all, you have to filter options, what it's supposed to be. They all are given E means that they all are trans. They are opposite. They all are trans. Okay. So it's easy. Then you have to give the name. Of course, the functional group is our priority. The functional group is our priority. So I would say that it's 1, then 2, then 3, then 4. So 2 methyl and 1 bromo. Okay. Bromine comes first as like alphabetical order. B comes before M. So it's 1 bromo. So we have 1 bromo. It may be A, it may be C. 1 bromo. Then 3 methyl. No, it's 2 methyl. So that's why option option D is correct because the double bond is at the first position. In A, they are saying that the double bond is at the second position. No, it's at the first position. So that's why D for doctor is correct. Okay.
Sir, for the previous question, from which topic is the previous question? The one before this one.
This one.
Yeah, this one. Where the hydrolyzed one. Which one is hydrolyzed?
Halogenoalkane. Halogenoalkane.
Okay.
Halogenoalkane. Okay. Then
Okay,
one
hydrolysis
bromo.
reaction, right?
Yes. One bromobutane reacts with an alkali. The mechanism and the type of reaction is when you can see bromine is substituted by this OH. Of course, bromine and OH both are nucleophiles. They are not electrophile. So C and D may be correct. Of course, C and D may be correct. It's not A and B because this is not electrophilic reaction. It's nucleo. Nucleophile means that it has negative charge. So is this addition or substitution? I told you in addition reaction
D.
only one product is formed. It should be D. It should be D. Okay, it should be D. Which of the following compound could be oxidized to a carboxylic acid by refluxing with potassium dichromate and dilute sulfuric acid? Potassium dichromate is an oxidizing agent like K2CR2O7. They are saying oxidized to a carboxylic acid. This is your secondary alcohol. This is your third. This is your secondary alcohol. This is secondary alcohol can be oxidized into ketone. Okay, alcohol can be oxidized into
Sir, can
ketone.
you repeat, please?
Sorry, tertiary alcohol cannot be oxidized. Tertiary alcohol gives no reaction with this oxidizing
You're
agent.
lagging.
Again, secondary alcohol can be oxidized into ketone. So option D is your correct option. Okay?
Can you repeat? You were lagging the whole time.
So how's it B? Or is it
D,
D?
because
I
this is
doubt.
primary alcohol. Primary alcohol can be oxidized to carboxylic
Oh, okay,
acid.
okay. I thought you
Yeah,
meant to
and
D.
secondary. Yeah, exactly. And secondary alcohol can be oxidized into ketone, and tertiary alcohol cannot be oxidized further. A student made the following statements about trends going down the group 2. Which statement is correct? Number A. The thermal stability of night, no, it increases. I told you. The thermal stability of the carbonates decreases. No, I told you increases. The solubility, yeah, I told you regarding the solubility and also the thermal stability. Okay, so the thermal stability of nitrate carbonate increases, and also the solubility of group 2 hydroxide increases, and also the solubility of group 2 sulfate decreases. See, these are the four statements that you need to memorize. Then,
Sir,
yes, Abdullah, bolo.
sir, the thermal stability of hydroxides decreases, right? Going down the group.
Increases of nitrate and carbonate.
No, of hydroxides. Thermal stability.
ये तो syllabus में ही नहीं है. Have you learned this?
Oh, okay.
Thermal stability of hydroxide.
Yeah, I
यहाँ
think
तो
we
कहीं पे
did
नहीं
that.
लिखा हुआ.
Cool.
Stability.
No, nitrates and sulfates, right?
A colorless
Sir,
solid
can
Q
we
was warmed.
somehow?
A colorless solid Q was warmed with sodium hydroxide solution. A gas was evolved which turned damp red litmus paper blue. Solid Q. Warm sodium hydroxide gas turned red litmus paper means it is a basic gas. It is a basic gas. You know, it's an ammonia gas. It's ammonia. Ammonia can be released from ammonium. Ammonia can be released from ammonium. Ammonium. We have only one option. We have only one option, that is B. That is B. Let me tell you an equation. When ammonium chloride is going to react with sodium hydroxide, it produces sodium chloride and ammonia and water. Simple. It's going to produce ammonia gas, which is a basic gas. It can turn your red litmus blue. Okay. Then they are saying in the next question, which test is used to show that sodium chloride solution contains chloride ions? So of course, chloride ions, then you have to test the chloride ion by adding the silver nitrate. It's going to give you the white precipitate. It's going to give you the white precipitate. So that's why
D.
the option is D for doctor. Okay, not
Sir, why
hydrochloric
is
acid.
this C?
If you remember, we used to add silver nitrate into the chloride solution, a sample which contains chloride. It's going to give us silver chloride, which is solid, and it's the white PPT. So if you can see the white precipitates after adding silver nitrate, which shows that the chloride ion were present, and that's the reason silver chloride was formed. And then we can see the white precipitate. It's the chemical
Yeah.
test for the presence of chloride ions. That's why option D
Yeah.
is correct.
So if we see cream or yellow, we're gonna say bromine or iodine,
Green,
right?
yes. Compound X gives a red flame test color and a white precipitate on addition of dilute hydrochloric acid, followed by barium chloride solution. Which compound is X? Okay. So first of all, red flame, red flame is for lithium. Red flame is for lithium. Okay. So it must be lithium. There is only one option. Okay. So that's why option B is correct. No need to check further. It would save your time.
Isn't
Okay.
strontium also white, red?
Sorry.
Isn't strontium also red?
No, they have not like strontium is red, but they are saying like in a white precipitate on addition of dilute hydrochloric acid followed by barium chloride solution.
So trace ions.
Whenever you can see the white PPT after the addition of barium chloride, as a result, barium sulfate would be formed. Barium sulfate is white solid. It's also the white precipitate. So then in option B, you can see the sulfate as well. Okay. Yeah, good one. Like strontium is again like is also the red flame color. So then we have to check anion as well. Okay. Good. Then you can see question number 12. Which process explains the flame color produced by the compounds of group 1 elements? Okay. So A, absorption of visible light. Energy as electrons are promoted to a higher energy level. Okay. Whenever we can see the color, whenever we can see the color, electrons are going to release energy. They are coming from higher to lower. They are coming from higher to lower. Emission, they are doing emission. Okay. Emission, we have two options, C and D. Okay. So of course C is correct, because electrons return to the lowest, to the lower energy level. So of course they would be releasing energy. So of course they would be releasing energy. Okay. Then you can see option question number 13. When chlorine is reacted with hot concentrated potassium hydroxide, the chlorine undergoes disproportionation. What are the oxidation states of chlorine in the products? So I believe that if you memorize this equation, so you would be able to solve this question very easily. Otherwise you have to suffer. Because this is the memorizing, because this is the test for your memorization. It's not the concept, I can say. So I remember this equation was when chlorine is going to react with sodium hydroxide, it was producing sodium chloride and also the sodium chloride, that is NaClO3. In this, it's -1 and it's +5. Okay, so that's why answer is B. So that's why answer is B.
Which I didn't understand.
Simple. You have to memorize this equation. Then you have to find out the oxidation state of chlorine. Simple.
Sir,
It's
but they
minus 1.
asked
It's plus 5.
for potassium. They didn't ask for sodium.
Oh, doesn't matter, man. It's KCl and KClO3. Simple. Simple. Okay.
Okay.
Yeah. What are the gaseous product formed rather than the water vapor when concentrated sulfuric acid is added to barium potassium bromide? What are the gaseous product formed? Bromine and sulfur dioxide only. Okay. When concentrated sulfuric acid is added to KBr, K is added to KBr. So then you must know the product. I remember when we were discussing group 7 halogens, group 17. So I told you at that time that we have redox reaction. When we have redox reaction, okay, when sulfuric acid is going to react with the sodium bromide or sodium chloride or sodium iodide, like that. So remember, it's also the memorization, so you must know what would be the product. Okay, so the answer is C. Bromine was forming along with HBr and along with the sulfur dioxide. Sulfuric acid is acting as an oxidizing agent over there. Sulfuric acid is acting as an oxidizing agent. So that's the reason sulfuric acid is itself reduced into sulfur dioxide. Sulfuric
So
acid is
when we write the oh, sorry. When we write the equation, do we write all the products together, like Br2, HBr, SO2 all together, or just one product?
no. You have to write all the things all together.
Even water, right?
Yeah, exactly.
Okay.
Because they would be asking the balanced chemical equation. They would be asking to write down the balanced chemical equation. Okay, now see this question number 15. See this question. Zinc metal reacts with copper sulfate solution. The equation for the reaction is this. What is the temperature rise in degrees Celsius when excess zinc powder is added to 50 centimeter cube of copper sulfate solution containing 0.0025 mole of copper 2 ions? Assume that the specific heat capacity for the solution is 4.2 joules per gram per degree Celsius. Yep.
Is it A?
Why? How? How? Yeah, this is A, but how?
You have to rearrange the equation for the enthalpy change.
Okay, so means you did this.
Yes, I did.
Okay, then
So I did 40 times 0.025 to give 0.525 kilojoules.
what is delta H?
Q over N.
Nice.
Enthalpy change.
Then
And then I equaled that to minus 210, because that's the enthalpy change.
and divided by
Divided by the 0.0025. No.
then
Oh yeah.
then what's the answer?
For that,
Yeah.
it's 0.525.
So then you put over there, right? Then mass.
No, I didn't do like that. I did a different method.
Okay.
I'm doing a
Then
different method. I equaled that
Okay.
The joules to Q equals MC delta T.
Like that.
Yes.
Okay. Then you found the temperature, right?
Yeah, yeah.
The same thing I was saying to you, that is MC. Delta
Oh,
H over MC, okay?
okay.
Mass. Mass is, uh, what is the mass? What is the mass?
So I was gonna do mass is equal to number of moles times mr.
Yeah, exactly. Then you would not be doing this, okay? Yeah.
Okay, sir. After that, what would I do? How would I find Q? For then to find T, right?
Yes. Basically, we have multiple methods to do this question. Roma, how did you do this question?
Sir, I did it the same way as Salma.
Yeah. अब्दुल्ला क्या कर रहे हो तुम कैसे कर रहे हो
Sir, Q
Enthalpy
कैसे
change
ढूंढेंगे?
MC delta T.
ऐसे
हाँ जी.
फिर then
So first we find the M by doing mass over molar mass.
okay वैसे by the way it's very simple question you can do this then if you are not getting the final answer then do let me know okay just leave this question you can do after this B option like B part the reaction of zinc with copper sulfate is best classified as it's a good question zinc plus copper sulfate what is this what's the type of reaction is this disproportionation is this neutralization is this redox is this thermal decomposition
Redox.
yeah exactly because zinc sulfate and copper would be the product. Copper is +2 over there and copper is 0 over there. It's +2 and it's 0. So copper is changing from +2 to 0, which shows that it's a redox reaction. Okay. So means that option C is correct. Magnesium metal reacts with hydrochloric acid, which change in condition would have no effect on the initial rate of this reaction. Rate, increase in the volume of acid solution increase in the volume of acid solution. So remember, we have different factors on which the rate depends. Of course, this is magnesium metal. Of course, it's solid. It's going to react with hydrochloric acid, which change in condition would have no effect on the initial rate of this reaction. So temperature is directly proportional to the rate. Surface area is directly proportional to the rate. Concentration is directly proportional to the rate. So of course, the answer is A. If you are going to change the volume of acid solution, so there will no effect on the rate of reaction. Okay, because in this magnesium we have magnesium. Okay, you know you are supposed to increase or decrease the concentration. Okay, then I can say that the rate of reaction would be changing. But if you're going to change the volume, so it would not be having any effect on the rate of reaction. See this, it's Boltzmann distribution curve. The diagram shows the general shape of a Maxwell-Boltzmann distribution curve for the particles present in a reaction mixture. How does the peak change when the temperature of the reaction mixture is decreased? So I told you in this we had two cases, like the decrease in temperature or the increase in temperature. If you are going to increase the temperature, so the height of the peak is going to decrease and the curve shifts towards the right. And if you are going to decrease the temperature, and if you are going to decrease the temperature, the height of the graph is going to increase and the graph shifts towards the left and the graph shift towards the left. So of course the
Is it
answer
C?
is A. The answer is A. It's very simple. The activation energy of an uncatalyzed reaction is represented by the
Is that
vertical
because
line.
the so is that because the activation energy increases? That's why it shifts to the left.
Activation energy doesn't change after increasing or decreasing the temperature. Activation energy is only affected by the addition of catalyst, I think so, if I'm not wrong. Yes or no?
So what was the reason for the shift to the left?
Because, when the temperature increases, so the number of particles would be having greater kinetic energy. Okay, the number of particles would be having greater kinetic energy. So of course, then the number of particles would be, like, you can say right now we have only 20 particles that are going to do reaction. So at that time we would be having 30 particles to do a chemical reaction. Okay, so whenever you are going to increase the temperature, just like that, the graph shifts towards the right and the height of the curve decreases. Now you have more particles in this area under the curve. What does it mean? So
It means
they
the temperature has increased, right?
Yeah, exactly. And they are asking the decrease in temperature. So that's why I'm saying that the graph shifts towards the left. The graph shifts towards the left, and the height of the graph and the height of the curve is going to be higher. Is going to be higher. Okay. So that's why option A is correct. Now B. The activation energy of an uncatalyzed reaction is represented by the vertical line EA. On the horizontal axis, the shaded area A and B are the areas under the curve on either side of the line EA. How do the two shaded area change, if at all, when a catalyst is added? After the addition of catalyst, the activation energy is going to decrease. Activation energy is going to be just like that after addition of catalyst. And this is the activation energy, like, you can say, like, let's suppose like represented by the word. This is for catalyst. This would be the activation energy. Okay, they are saying how do the two shaded area change if when the catalyst is added? So of course, shaded area, the shaded area be just like that. I'm not. So area A, area A decreases. Area A decreases. Area increases. Simple. It's B. It's a baby question. What is this? This unit 2, man. Shaded area. Oh my god, it's the drawing paper. It's very easy paper. Then equilibrium in the equation was studied place the constant field class at equilibrium, which the following statements is true.
There you're lagging.
Ah, but all of you I'm lagging.
Yes, sir.
Yes, sir.
Can you please repeat?
I'm this is question number 18. Okay. What's the answer?
D.
C.
C.
D. Exactly.
No, no, that's
At
true.
equilibrium, the rate of forward reaction is equal to the rate of backward reaction. They can never stop. Never stop. The particles are always in random motion. That's why C is your correct option. Yeah. 2-methylpropane 1-ol has the skeletal formula. Give the reagents and conditions used for this reaction. 2-methylpropane 1-ol can be converted to a 1-bromo, can be converted to a 1-bromo 2-methylpropane. So of course it can be substituted by the bromine. So which reagent I am supposed to take to convert this OH into the bromine? Of course it should be potassium bromide. You can take sodium bromide. Nah, potassium bromide, and then uh, sulfuric acid as a
Is it under
catalyst.
reflux?
It's understood. It's heat under reflux, okay? Because we have a bromine that is from halogenoalkane, okay? Always heat under reflux.
So condition
So
is heat and
A,
reflux, right?
B are
Sir, whenever we have an organic compound, we always heat under reflux, right?
We always have halogenoalkane, then we do heat under reflux.
Okay.
Identify and correct the three mistakes in the mechanism shown. This arrow should be like that. This arrow should be like that.
Br is positive. Br is partially positive.
Okay. And this carbon is partial positive. And
And they are partially negative.
we are partially negative. Simple.
Should we
Arrow
draw? I think.
Oh, so the OH is supposed to attack, right? The carbocation, right?
between carbon and OH
Don't we need the
should be
lone pair on
reversed.
OH?
Should be reversed. Okay, should be reversed.
So the nucleophile is the OH, right?
Yeah,
Okay.
should be reversed. And of course, on OH, the lone pairs are missing. Okay,
Okay.
one bromo, two
Sir,
methyl propane.
why is the carbon bromide bond supposed to be reversed?
Bromine is electronegative. It's supposed to have a negative charge. That's why. One bromo, two methyl propane can be converted to two methyl propene. Give the reagents and condition. One bromo, two methyl propane is this. One bromo, two methyl. One bromo, two methyl propane. One bromo is this. And 2-methyl is this.
What is it? Potassium
Is
hydroxide.
converted into this one. So of course they are removing this one HBr. HBr is an acid. So you need to add potassium hydroxide, okay, in ethanol. Potassium hydroxide.
Ethanolic potassium hydroxide.
Yeah, exactly. Okay. And okay, simple. Oh, it's of 2 Mars. Calculate the mass of
Can you go
ethane.
up so I can take a screenshot? Okay, thank you.
Calculate the mass of ethane dioic acid. Should be used to make this one. Give your answer to an appropriate number. Okay. Okay. Can you tell me an answer?
So it's going to be 0.0500 times 90.
Moles of ethane dioic.
So is it 4.5?
0.05, the same mole. Okay. And then since the mole ratio of ethane dioic acid, okay, ethane dioic acid is a solid diprotic acid. A student used ethane dioic acid in titration to find the concentration of potassium hydroxide solution. Okay. Uh, the equation for the reaction is this. Calculate the mass of ethane dioic acid that should be used to make 100,000 cm cube of a solution in water. Give your answer. Okay, these are the moles. Okay. And then I have to find out the mass. Mass is equal to Mr. Moles. MR of ethane dioic acid is 90 times 0.05. Then I would be getting the answer. What's the answer?
4.5.
4.5.
4.5.
So, sir, the ethanoic acid from the reactant side, right?
This is ethane dioic acid.
Okay, so we found the molar mass of this.
It's just like that. Okay.
So is it going to be times 2? Because look, it has 2 beneath it after the bracket.
So is the overall molecular mass 90
Okay.
after times 2. Okay.
Okay.
Yep. A student decided to check to see if phenolphthalein was a suitable indicator. Phenolphthalein was a suitable indicator. Okay. For this titration, the student measured 40 cm 400 cm cube of 0.0500 mole per dm cube ethane dioic acid into a beaker and added a few drops of phenolphthalein indicator. Calculate the minimum mass of solid potassium hydroxide should be used to produce a color change. Okay. Okay, 400 mole of ethane dioic acid is equal to concentration multiplied by volume. So what's the answer? What's the answer?
0.02.
Yes.
Mole ratio between potassium hydroxide and ethane dioic acid was 2:1. I got the mole of this one. This would be X. X would be equal to 0.04 mole of KOH. I need to find the mass is equal to Mr. Moles. I got the mole, that is 0.04 times MR of potassium hydroxide, that is potassium hydroxide. I don't know what's the mass. What's the MR? K is 39 plus 16 plus 1. I think so it's 56. What's the answer?
0.24.
0.
2.24.
Oh, 2.24. 2.24 grams. Okay, simple, easy.